Hi again. So I'm going to show you how to run these models in Excel. Last time I went over how to do them by hand. Usually this one was set up from just looking at Dr. Cottom's data, but thinking about it in data first and then turning it into a model. But now here we're going to automate this so that I don't have to do row by row each time. And we care about doing it this way because, as Dr. Cardell mentioned, that persistence rate, which is the same thing for clinical dropout, is important, and that the National Institutes of Health ask for a 70% persistence rate, just like the Organization for Bariatric Surgeons asked for. But she got it up to 0.85. If I really want to see those numbers projected, I'd have to be able to change this persistence rate. So let me show you how to automate this in Excel. So here I have the clinical visit. I label things by the variable. And in our class, I don't ask a lot, but the things I ask for is neatness in labeling your headers because it makes your graphs turn out pretty nice in the end. So good fundamentals. Write down what this means. It's actually not fake math, it's real math, so we need to know what this coordinate means. It's the clinic visit. The number of patients at clinical visit, N, which we labeled in math terms as PN. That's just our lingo for what this is, a shorthand for this number of patients at clinical visit N. And the persistence rate, I'm going to keep it outside, and you'll see why. Okay, so now, I want to actually go from clinical visit number 0 to number 1. So what I'm going to do is put an equal sign, A2, because this 0 is in cell A2, and I'm going to add 1. And I did it this way for a reason, because if I pull this down, it will fill in all these numbers below. So clinical visit number 2, 3, 4, 5, 6, 7, all the way up to 13. I just pulled it down to 13, but you can pull it down as far as you want. Same thing here. What am I doing? I'm taking the 100 from this table and multiplying it by the persistence rate to get 70. So the persistence rate is in cell C2, but I don't want that to scroll down, because if I scroll it down, if you go look here, for example, here it says A3 plus 2. So pulling this down in that way led to this number being moved up by 1. I don't want to go to cell C3. So here's how you do it. You do equals, and instead of typing 0.70, you're going to type C2. But here, you're going to put a dollar symbol in between the C and 2. And what that does is it makes sure that number stays fixed. So I took the previous number, which was 100, that is in cell B2, and I multiplied it times this 0.70. And I hit enter, and you see I get the same number 70. Now, proof in concept, let's pull it down 1 and see if we get 49. We do. And if you look here, it's taking 0.70, which is in cell C2, and then multiplying it by the value in cell B3. So, don't do that. So now you can pull this down all the way, and you can see what happens. Eventually, you're going to get nobody coming back for follow-up clinical visits, which is what they see, which is what you'd hope to see. Eventually, you'd want to not come back anymore. So let's look at this in a graph. And this is where it's nice to have nice headers. Insert, charts. I like to see it like this because it's connected. And you can see the number of patients that return each clinical visit is represented by the dot, but this is artificial connecting the dots, but it lets our eyes see the pattern of this prediction. Now what's nice about the way I've done it is if I want to go here and put in Dr. Cardell's 85%, I can just change this 0.75 to 0.85, and all the numbers automatically change, and you see that was a big deal to get that persistence rate to change to 85. And as you saw in the video, she was very proud of the fact they got it to 85%. So what we're going to investigate in this class is trying to figure out what the model is in general for anything where it requires humans to continue doing something. Could be going back to the gym again. It could be just doing their WebAssign homework. It could be coming back for your follow-up clinical trial visit. It could be coming back for your follow-up following surgery, anything like that, we're going to model it. And if we keep it up and you're really interested in it, I'd like to write this up as a manuscript and bring everybody in, because I think this is human nature and we have a way to model it. So that's how to get your basic DDS. Now, if you have something else in here, the laws all stay the same. And so we're going to continue doing this in class. And so today, I want you to be able to do exactly what I did here, and then, and start changing around the numbers and get the same graph. So recreate what I have.